Alright, so the main mites, two-spotted mite, which is TSM, ARM, which is European red mite, and Barabia mite. They're the ones that you're most likely to see around here. European red mite isn't widespread in the Goulburn Valley, but it is in a lot of other districts, and certainly in New South Wales, Tasmania, parts of Queensland. You'll find it around there. It's not in the west, but it is certainly starting over the last few years. It's started down the road a bit in the Goulburn Valley. Barabia mite generally is something which it comes in once you stop using a whole lot of broad spectrum pesticides. But we'll get to that in a minute. And then there's these other real small ones, the rust mites, beach silver mite, blister mite, all tiny little things which we'll cover off. And then the rest of what's on the list there are things that you don't really need to worry about, but if you're not sure what they look like, you might count them as mites that you need to control. So let's have a look at two-spotted mite. We've switching over to this sort of medium. We don't have too many really good photos, but from my early days as an artist, there's the life cycle of two-spotted mite. And the interesting thing is that if you look at the adults, it's got 8 legs. If you look at the larva, which is what hatches out of the egg, it's only got 6. And then as it gets older, it grows an extra pair of legs. So if you thought that was an insect when you're looking under your hand lens, it probably isn't. You can see here, that's the male, and they're more pointed in their abdomen compared to the female. There's adult females, and you can only just see the eggs there. And with the overwintering, they turn orange, so these are overwintering females. And then we've got the sort of damage they'll do on pairs, which we'll see a bit later. So, in terms of its overall life cycle, once the food conditions are pretty poor, they'll start to go orange, the males die off, the females hibernate until conditions are right. The female will generally resume activity in spring, and because all the males have died off, the first lot of eggs she lays become males, which then mate with the females that have been left, so in other words, their mothers and aunts and all that sort of stuff. And then once they fertilise those females, they'll produce more females. The life cycle, about 3 to 5 days for hatch, and from egg to adult, about 7 to 14 days on optimal conditions. So they can go through a number of generations really quickly. They'll produce anything from 3 to 14 eggs a day. The average female puts out about 70, and the maximum they can do is 200. So you can see that populations can build up really quickly, so you need to be monitoring that fairly carefully. And their optimal temperature is 30 to 32. Now that doesn't mean if it's an ambient temperature of 40 they're going to keel over, because this temperature is what they experience on the surface of the leaf. So you've got a bit of transpiration and things like that. So it's not always the same as the ambient air temperature. And one thing to remember for two-spotted mite is it usually will start in the crotch of the tree, and the infestation works up and out, because the females are actually overwintering down in that part of the tree. So as it builds up, it'll go up and out, which is different to European red mite and Barabia mite. So with European red mite, the eggs look like an onion, and they've actually got a stalk on them. You can see that under a hand lens if you know what you're looking for, but it's best under a microscope. So for you guys in the field, it's not a great deal of help, except for where it's actually located. And if you've got a good eye with the hand lens, you can see that little stalk. But the other bit is it sort of looks striated. And I haven't got a good photo of Barabia mite eggs, but they're red as well, but they're globular. And they don't have that striated sort of mark on it, and they don't have a spine. So this adult female European red, so that red body, it's got these white tubercles where the hairs come out of its back. That's pretty distinctive. Again, the male, similar shape to two-spotted mite, but the damage is different. So although that's an apple leaf, but it tends to be stippled rather than causing burn. With Bryobia mite, they're pretty easy to pick because they've got these long front legs. They're fairly flat and they're more of a darkish brown. The big problem with them though is that they don't feed on the leaf much during the day. So if you're going out doing your monitoring this time of day, you actually need to look on the twigs on the wood and you'll see it moving or hiding just on the wood during the day. So first thing in the morning, late afternoon, they'll start to move out and you can find them on the leaves, but during the day, they won't always be on the leaf. And that's the sort of damage they can do. That's on cherries, that one. So it can be fairly devastating if they get really crazy. Okay, so European red eggs are actually, they are winter as eggs, not as adult females. The eggs are laid all around the buds, which means they're all over the tree. They'll hatch around about green tip. The mites will then generally be on both sides of the leaves, whereas with two-spotted mite, until the population gets big, they'll usually be on the underside. The damage will be scattered all over the place, and it's mostly leaf speckling. The infestation, as opposed to what happens with two-spotted mite, the infestation of the European red and Bryobia specifically starts basically wherever the eggs are being, so on that outer part of the tree. And they don't produce much webbing. They're still called spider mites, but they don't produce much webbing. And unfortunately with these guys, their eggs tend to resist the predatory mites. They're just a bit too tough for predatory mites to pierce. So the predatory mites will eat their larvae and nymphs and the adults, but they don't do much on the eggs, whereas with two-spotted mite, the predators really like the eggs as well. And these guys have a lower optimal temperature, so it's about 25 to 28. Bryobia, again, red eggs on the spurs. That's about the same time as European red. In some ways, if you've got Bryobia, you're better off than having European red because they can sort of compete a bit and they don't do quite as much damage. Like I said, normally they'll be on the twigs near the leaves during the day. And the rest of it's pretty much the same as with European red, except their development is fast in hot, dry weather. It slows down in wet weather, so the sort of weather we've had over the, leading up to December, and that wouldn't be conducive to them all that much. So, with pears, which is what we're here to talk about today, one of the effects of mites feeding on pears is you get scorch. And that scorch can look like the same scorch you get from salt or various other things as well. So you need to sort of weigh up and you're in a poor drainage area or whatever else. And if you are in a poor drainage area, it even compounds it a bit because if the trees get stressed a bit more, the mites tend to build up and create even more damage. So water stress, either from not enough water or too much water, can cause problems. But good thing is it will develop in a predictable response to the mite pressure. So just hold that thought because we're going to come to that in a few minutes. The other mites that are out there, this is pear leaf blister mite. They get these little blisters on the leaves. This is what we call an areophyte mite. They're really tiny, that's 7 there. They look like little worms or little maggots. If you look carefully, you can just see some legs at the head end. But they're about roughly 0.015 millimetres long. So they're pretty bloody small, right? About the size of the leg of a two-spotted mite. So they are hard to see, but what you'll see is this silvering effect on the leaves, or in the case of pears, you'll get the blistering. They'll overwinter on in the buds. Now in the bark scales, they're going to move to the expanding leaves. So as those leaves start to open up, they'll get into there because they come out of the bud and go onto that. They don't lay as many eggs, so 4 eggs a day. They might average 87 eggs each, and that's around about 22 degrees, so that's spring sort of temperatures. But they'll go through generation in 10 days, all right? And again, they'll start to produce overwintering females in late summer, autumn. So we're almost coming up to that period now. If you've got populations below about 300 per leaf, they're not an issue. In fact, they're beneficial in some ways because the predatory mites love to eat them. So if they're there early, which is what they do, they come out of the buds and they're there early, your predators actually get a good feed out of them, and then when two-spotted European red mite comes around, you've got a good population of predators to take care of. So you just need to weigh up the benefits of knocking them off. If you've got lots and lots of blister mite, yes, you might want to think about controlling that. But other than that, I'd say in most cases, let them rip. These are the ones, I haven't got any decent photos of these, they just go by the shapes. There's what we call false spider mites. They've got these big shoulders on them, they're slow moving, and they just sort of sit there on the leaf and not do much. They're, everyone's pretty ambiguous about that. They don't really do much, so you don't need to worry about them at all. Carcinemids, which are these little guys, they're more of a problem in ornamentals. Occasionally they can get into the buds and they can cause some deformities there, but generally they're not much of a problem. And the tidaids are more fungal feeders and things like that. So if you've got a bit of fungus there, they'll feed on those ones. You can usually tell from the colours and the shape that they're not two-spotted mites, and they're fairly slow as well. So basically, don't worry too much about those. I want to put this up because it's really important when you think about mite control, what you're doing for everything else. So this is an old slide based around what we used to do for codling moth. So in the good old days of azinphos, methyl, or DDT and all this and stuff, you targeted this stage here. So the eggs were about to hatch or they were just hatching, and you tried to stop the larvae from getting into the fruit. So you put your pesticide on there. That was all very fine, except that those pesticides had a whole lot of problems. They killed off beneficials, resistance developed to DDT, not so much azinphos methyl until more recently. There was pollution effects that worried people, there was pesticide residues on fruit and all that sort of thing, and they started to cost a bit of money. So there was a big program put in place to have a look at, well, what's going on here, because we're getting mite outbreaks all over the place. And it turns out that this death of beneficials, they were killing off all the staphylococcus, they were killing off a whole lot of predatory mites that were in the system doing the job for you, but nobody recognised they were there. So we did a heap of work on how we could actually sort that out. And we brought in predatory mites, which I'm going to cover in a second. But the other bit with the chemical control is the products are very much timing dependent. So if you're using products for mite control, you need to know, is it going to kill the eggs? Is it going to kill the immatures? Will it just knock off adults? How does it work? What does it do? And how many applications can I put on in a season before I get anywhere near getting some resistance? The other thing is, if the population gets too big and they start to produce webbing, that webbing gets dust over it as well, and they feed underneath the webbing. So when you're spraying, it's really difficult to get in contact with a contact pesticide onto the mites. And I haven't bought any miticides for a long time, but you guys can tell me, they used to be the most expensive pesticides you could buy, so you didn't want to be using too many of them. We got resistance to the organotins, we got resistance to herbicides, we got resistance to almost all miticides that were out there because people started to overuse them. And a good example of what I call a numbers game is with glifenazine. When it first came out, they only worked on, they did all their trial work on a couple of orchards, and they had about 5 years worth of applications out there, so 1 or 2 applications a year. when it finally got registered, the guy who had those trials on his place thought, well, they work really well, I'll continue to use them. He got 2 seasons out of it before resistance blew it out of the water. So you're only talking 10, 12 applications most at max before they start to get resistance. So every chemical's got its own mode of action, its own way that it's going to work, and you really need to protect those chemicals in the system. And yeah, there was a fair bit of misunderstanding about resistance management. So, you know, if you were using Plictran and then you want to swap over to Talk or whatever, well, that was stupid because they're both in the same group. People understand a lot better now, I hope they do anyway, the use of the different activity groups with chemicals. So you want to make sure you're not using stuff in the same activity group. The Golden Valley actually had the reputation of the graveyard of mycelids for the world. So if they wanted to know what was likely to happen with the resistance, they actually looked to the Golden Valley to see where was their next problem. So what did we do? We brought in some predatory mites, and luckily enough, well, the reason we brought them in was they were resistant to a lot of pesticides that were being used in the orchard at the time. The one that was most common, and the one that we brought in 72, was Tiflodramus occidentalis. You'll see it's had a name change. That's what taxonomists do. They like to keep themselves in the job, so they write a paper every 5 years reviewing the names and change the names. But that's hung around for a while now. That once they go on Dromus, you'll hear of more often now than Tiflodramus. And we brought in a carbamate resistant version in 1980 as well. Now these were released all through the Golden Valley, free of charge, put out into every orchard in the Golden Valley, and started to do a really good job. For southern Victoria, where they had European red mite, and New South Wales, where they had European red mite, we brought in a pyrethroid resistant same genus, so it's Gallindromus pyri, came in 83, because we finally got European red mite from Tasmania into the mainland, so we had to control that one. And there's a whole range of other species that are out there that survive. There's a Chilean spider mite, predatory mite, a few others which are available commercially as well, which all do a good job. But anyway, by bringing these guys in, we reduced miticide by better than 70%. So for many years up until the growers were getting away with no sprays at all. Whereas before that, they were putting out anything up to 8 or 9 miticide sprays a year. So since then we haven't had too much resistance issues, and Steteris and other predators are now back in the system as well, because we've changed what we do for codling moth and Oreo fruit moth as well. So it shows you how they can sort of impact. So in terms of those predatory mites, I put this one up because this is really historical for this site. So this area is the car park at the back of this place. And we used to grow soybeans up there and infest them with two-spotted mite, and then get the predators going, and then we harvest them and take those around and put them in all the orchards. There's our predator, that's occidentalis, and it's feeding on overwintering two-spotted mite in that case. And there's the other one, pyri, feeding on European red mite. Okay, so I mentioned western predatory mite. That's what they call the Tiflodramus, now Gallindromus. That's what it looks like. It's sort of a pearly colour, teardrop sort of shape, and you can't see the hairs on it, but it's generally, what would you call it? It's not very reflective. Whereas if you look at these guys here, then you can see the light shining on them. So again, depending on what they feed on, they might be looking like that, or you might actually see some of the gut contents, so it gives them that sort of darker coloration inside them. And is again pyri, which has different hair patterns which you can't see on bit of handlings, but its behaviour is a lot different when it's feeding on European red mine. So it tends to be slower. These guys, they move around a bit, but they like to tuck in under the veins on the leaf. This guy here, which is the Chilean predatory mite, Phytoceolus pessimus, is big, it's red, it's hungry, it eats its own kids. It's a real mongrel, but it does a really good job of mites. And that's the one that's commercially available most readily. But its immatures look a bit like this one here, which look like these other predatory mites. So they tend to be flatter than what these guys are, but they move around really fast. So if you see something like that that's moving around fast, it's a good chance you've got pessimus in the system. And then this one is a native one that's been found in a lot of horticultural enterprises, and it's called Useus victoriensis. It used to have a different genus name, but it goes by the name of Victoria. So it's actually found in Victoria anyway. So that one there is available for some of the rust mites as well. Right, so the main thing is this combination. So it's about management, it's about combining all your tools and about optimising what you do, alright? So it's a really important thing, and the reason I had that up there because it leads into this slide, which is all about thresholds, because IPM, because it's management, it relies on having thresholds for activity. So you can say, okay, I've detected some mites. Do I need to do anything? Well, refer to the action threshold. Have I got them too far and they're above my economic threshold and I really should have done something beforehand? So you've got two sort of thresholds. The action threshold is where you intervene to stop it getting past your economic threshold. Okay? So you need to consider that whenever you read stuff in the literature. Every crop, every variety has its own threshold. And every grower has their own threshold, because I keep putting this up because it seems to be a good way for people to understand it. The grower threshold is similar to a pain response. It's a pain in your back pocket or in your wallet, whichever place you put your wallet. Everyone's got their own level of tolerance. You work out how far you can do it based on your own situation. So we can give you some guidelines. We can say, if it gets to this level, it's going to cause you pain, but it's up to you to decide how you deal with that pain. Alright, so the other thing to consider is what actually drives the level of pest attack. So I've mentioned optimum temperatures. These things, they're not insects, they're mites, but they're close to insects. So they're cold-blooded, they don't regulate their temperature. Their growth rate increases with temperature until it gets to a point where it's too hot and their enzyme systems all pack up and they react like us and kill over. So there's a fairly good gradation there in terms of the weather. So the warmer it is generally, the more rapidly they grow. If you've got a big population carried over from last year, you've already got a fair number there ready, waiting to go, so that has to be considered. And then also you've got the predation, so how many predators have you got in there? Have they survived over winter because there's no predators, or what's going on with them, right? So that drives it. The other bit in terms of that overall level is it's relative to crop growth. So I already said European red mite parabia and the Eriophytes usually come out at bud break. So they're already waiting there. That's an early infestation that can have more damage than something which comes out much later in the season. So if you happen to then get a build-up close to harvest, what are you going to do about it? Can you actually apply something which will knock that population down enough so you can get the harvest done and then do something about them later so that you don't have any residues? And then again, that leads to the efficacy of the control measures. So if you've only got weak miticides available, then you need to probably intervene a little bit earlier than if you've got something that'll work on eggs, nymphs, larvae, adults, and whether or not you've got resistance. And you should know whether you've got resistance by how much it carries over at the end of the year. So, how do we know all this? How do we find out what the population's done? In the old days, you used to have to take the leaves and you count every single mite on the leaf, and you'd work out how many mites per leaf there were, and you'd make a decision. When I first started with the department, I didn't wear those. After umpteen years of looking down a microscope at bloody mites, I've had to resort to this sort of stuff. But counting every mite per leaf is a pain in the neck. Literally, a pain in the neck is really that microscope. But it takes forever. And if you miss one or two, does it really matter? No. What we found was when we analysed that data was that there's a really good correlation between the percentage of leaves that are infested and the number of mites per leaf. So then all you have to do was say, yeah, that leaf's got mites on it, that one's got mites, that one doesn't, and you work out your percentage leaves infested. So that gave us a quicker way of assessing it. And you could also then have a look at something like this, where we looked at how many samples did we need to take, how much variation were we getting, and could we actually get our thresholds reasonably well. And so it turns out that if we were looking at percentage infested leaves here, and I don't remember to read this one because it's a while since I looked at it, the sample size. So a sample size of about 50 leaves gave us about the ability to pick up, say, accurately a 10% infestation. So with pears, I used to say if you had more than 3 mites per leaf, you're in big trouble, which worked out about 10% leaves infested. So it was a quick and easy way to do that. Then we got a bit smarter a bit later on. We started to look at, is it just when they hit that, or has it got more to do with how long they've been feeding? And so we came up with what we call cumulative leaf infested days, which I'm about to move to. So if you look at the leaf area that's been defoliated by scorch, which is down there, and you look at your cumulative leaf infested days, there's a pretty good relationship there. There's a bit of fuss in it, but it's a pretty good relationship. And so we started to have a good hard look at this. This is what you see if you just do percentage leaves infested, so you get your populations up and down depending on what you've done. So you put a spray here, yes, they've dropped down, that's pretty good. But have I had them out there so long that they've caused damage on the leaf? If you convert it to cumulative leaf infested days, you can see you get a nice curve and you can actually predict what's going on. So around about here, you'd say, oh, if that keeps going, it's going to hit there by February. Maybe I need to do something about it. In this case here, it's gone all the way through. There's February. You've just hit the threshold, which is the 5% leaf scorch, and you don't want to let it go past there. So whatever happens from then on, you've got to stop that population from expanding. So it's a difficult concept for some people to think about. Mick, you're still using plits or not? Yep. So I'll just give you an example of how to work it out for you. So there's your relationship between scorch and your cumulative leaf infested days for Williams pears. Okay? So 5% scorch is equivalent to about 1,500 cumulative leaf infested days. Cumulative leaf infested days works off percentage leaves infested. So in this bit here, we've got 2, 4, 6, 15 as we go through the season. There's your leaf infested days, which you work out by taking the 2 sample dates, the results from those 2 sample dates, add them together, so 2 plus 4 is 6, divided by 2 gives you, come on, 3. Multiplied by 7, because there's 7 days before then, you get 21, okay? So you've scored 21 leaf infested days. If you want to accumulate it, you add it to the previous one. So we had 2 back here, so 2 plus 21 equals 23. Okay, it's pretty simple really. And you just keep adding that up, which is what you get here. So there's our bit of maths. You just keep on accumulating those as you go through and you get up to here. So in this case, we've hit 1400, so we're not quite at that 1500 mark. Okay. Now we've got some of Wendy's handiwork. So Wendy's been doing work out in the pairs that you're going to go and have a look at, and we've split it up into varieties. I hope you can see that. It's a pretty dodgy one.
I can.
Right, so this one is the stone fruit. This line here is Lanya. This one's Deliza. This one's 534. And this one here is the pairs into canopy, which you'll see when we go out there. There's 2 things to watch here. One is that we didn't get anything showing up until 19th of December. So anybody who was putting the spray out here for mice was wasting their money. Right? So this is when the mites start to show up. They're building up. If you have a look at these, you're not going to have to worry about them for the season. This one here and this one, this ends on the 30th of January, so we haven't got the last couple of days' work in here. But this one here, I would think by now is probably hit the threshold. Now that's for Williams. What we're seeing out there with the way these different varieties are responding, they're going to have different thresholds for the scores. So that in itself is a really important thing to think about, because things like red sensation can have about 30 times the mite population that Williams pears can without that many dramas. Right? So it gives you that opportunity to manage the mite population, but also your costs.